Hi everyone, in this video we will create a drawing machine. This fantastic plotter can write on any flat surface, or almost. It can use any pencil, ballpoint pen, and even pen fountain, having the ability to tilt the pen. It is a new version of an XY plotter using a single belt and two-stepper motors in a configuration called HBOT. I saw a demonstration video for the first time, and I immediately wanted to have one. Thanks to Misen's work, I started printing plastic parts in 3D. Searching the web, I later found a shop where to find the hardware parts, and I just got to work. Let's see what's needed. Follow me. I bought all the hardware at Thingy Box. Inside there is a letter informing us of manual packaging, and therefore, in case you miss something, to contact them to resolve the problem. You can find the 3D parts in the video link description. We will therefore need 2 NEMA 17-stepper, 4 8mm smooth rods, 2 400 mm long and 2 320 mm long, 8 LM8UU, 2 20-tooth GT2 pulleys, 10 F623ZZ bearings, 1 micro servo SG90 plus a 250mm cable extender, 1 Arduino Uno, 1 CNC Shield, 2 Pololu step sticks, 1 GT2 belt, 1.4 meters long, 2 M10 threaded rods, 400 mm long each, 8 M10 nuts, 8 30mm M3 screws with nuts, 8 6mm M3 screws, 4 16mm M3 screws with nuts, 2 15mm M3 screws, 4 M3 washers, 2 4mm OD 100 mm long carbon fiber tubes, 1 12V6A power supply, 1 USB cable, 1 felt tip pen, or many for more fun. Thingy Box also shipped other accessories. Thank you. Good. Assemble everything in 20 easy steps. 1. Slide 2 LM8UU in each of the 2 longest smooth rods. 2. Slide the rods into the motor pieces, 1 on each side. Leave an extra 20mm of the rods in one of the 2 sides protruding from the part towards the motor. This will later be used for supporting the Arduino holder. 3. Insert the M10 threaded rods so each one supports one side of the motor supporting pieces using a nut on each side. Total 8 M10 nuts. 4. Mount the NEMA 17-stepper motors on the 2 big plastic parts using 8 cubic meters screws, 8 mm long. 5. Insert 8 cubic meters nuts into the nut holders in the bottom squared carriage, and place it supporting the LM8UU linear bearings you inserted in the long smooth rods already installed. 6. Take the remaining, shorter, 2 smooth rods, and insert 2 LM8UU linear bearings on each one of them. 7. Insert the 2 ND parts on each end of the pair of smooth rods. Now you have the second axis done. 8. Insert the top square carriage over the 4 linear bearings of the shorter smooth rods. 9. Insert 4 M30 30mm long screws in the 4 central holes of the top square carriage. Put the carriage upside down carefully so the head of the screws will lay on the table and the screws will point upward. 10. Insert one F623ZZ bearing with the flange down, next an M3 washer, and finally another bearing, but now with the flange up, into each one of the 4 screws of the top square carriage. 11. Use a post-it or a similar sized piece of paper to press it against each one of the screws protruding so paper is perforated and is pressing against the top of the bearings. The goal is for this paper to hold them in place while we put the whole thing upside down, preventing the bearings to fall off. 12. Place the top carriage over the bottom carriage so the smooth rods on the top form a right angle with the bottom smooth rods. 13. Screw lightly each one of the 4 M3 screws, and once you notice each one is attached to the nut in the bottom, tear the posted paper apart. Next, finish tightening the screws, and add the other 4 cubic meters 30mm screws that do not have a bearing but add strength to the union of top and bottom parts of the carriage. 14. Place one GT2 pulley on each stepper motor but do not tighten the grub bolt yet. 15. Place a pair of F623ZZ bearings with an M3 washer in between, fixed with an M3 screw in the end Y part that will support the servo part. 16. Insert the belt well along its path. The crossings of the central carriage are a bit tricky, and once pulleys are aligned with the belt, tighten the grub screws on each one. 17. Use 2 M3 screws and 2 nuts to attach the servo support part, and later add the micro servo using the 2 screws that come with it. Using a couple of M3 screws and nuts, fix the pen holder part to the vertical carriage. 19. Make sure the vertical 2 holes in the servo support part are 4mm diameter and that the carbon fiber tubes can be inserted into them. If not, drill the holes with a 4mm drill bit. Insert both tubes from the top but only midway, and next insert from the top the vertical carriage, the one that looks like a smiling face. Gently push it down till you can insert the remaining half of the carbon fiber tubes so they are inserted into the bottom holes of this carriage. 20. Push the Arduino holder into the protruding smooth rods on one of the stepper motor holders. Use a couple of M3 screws to attach the Arduino board to the plastic holder. Compliments. The mechanical part is over. Now we'll see the software part, and finally we will see the part about the wiring. We open the instructable page, and we look for missing Axidraw. Let's go to the third step. Load Arduino firmware. And we download this version GRBL, modified to be able to use a servo motor. This will be its content. While explaining how to vary the movement of the servo motor, within this file, you can change the program. The servo motor will be connected to the Arduino pin called D11. And you will use the M3 commands to move the servo motor from 0 to 180 degrees, where XXX can be a numeric value from 0 to 255. Step 4 shows an extra harness to give more force to the servo motor. Ms. Ann recommends connecting a piece of cable from the positive pole of the terminal strip to the pin of the VIN of Arduino, as you are seeing from the photo. Step 5. Computer software. First, we would need a special plugin for Inkscape. With Inkscape, we will create the G-code, starting with an image. To install this plugin, we will follow the step-by-step description of the page. We will also need to download Python, exactly the 32-bit version 2.7.9. Let's download the zip. Now we open the Python page and download the version shown. The next and last step is to download Code Sender, a Java program, which will allow you to send our code directly to our plotter. Universal G Code Sender. And download the latest stable version. As mentioned above, for the latter program, you will need to have a recent version of Java installed on your PC, so let's go get it. Once the Universal G Code Sender has been opened, some parameters will need to be modified in order to obtain correct calibration of the X and Y axis displacements. By typing $$, the list will be displayed with its GRBL parameters. Parameter 100 and 101 will be to be varied. We wait for the download deadline. And thank Ms. Ann for the great work he has done. Very well, let's start with the installation. The first step is to send it to Arduino Uno, the program GRBL plus servo motor. To do this, we need the latest version of Arduino IDE. If you do not already own it, go to Arduino CC and retrieve it. Once you open Arduino IDE, let's go to Sketch and click on Include Library. Next, add library from .zip. Here we will highlight the library GRBL, servo, master. Now, let's go to File, Examples, and go to the voice, GRBL, servo, master. And click on GRBL Upload. Close the old window. This will be our program to send to the card. Before uploading, we must make sure you have selected the correct Arduino card and the right door. The doors are slightly different in Windows environment. Find the correct one with some tests. We complement the program, and if there are no serious mistakes, we upload to Arduino Uno. Well, upload completed. Second step, we install Python, run the .pkg file, and follow the installation until the end. Third step, let's add Inkscape the correct plugin. We open the folder Laser Code Exporter Inkscape Master Plugin, open a new window and enter the Inkscape folder. We open Content, Resources, Share, Inkscape, Extensions. Here, exactly within the Extensions folder, we should drag the two files with extension .inx and .py. Fourth step, we check to have the plugin inside Inkscape. Let's go on Extensions, Export, and make sure we get the voice, turnkey laser exporter. Perfect. Already we have open Inkscape. We can immediately generate a test code file. Before we begin, we must set our worksheet. Let's go to File, Document Properties, set the unit in pixels, and insert the pixel dimensions of our want. In my case, an A4, 300 dpi, will have these values. For convenience, we set the default unit in millimeters. Now we can draw text. At the end, we click on Track, Drawing by Track. Now we are ready to export to code. We give the desired name, ensuring the correct extension code. We'll find him in the desk, and let's do it, apply. Perfect. We have the file, .g code. Fifth step, we install the Java program. We follow the installation guidelines. Perfect. This passage probably does not work. I have also installed the development version of Java 8. I recommend you try the light version of Java, and only if you have trouble, to proceed with this 500 megabyte version. Sixth step, we open Universal G Code Sender. We open the folder, version 1. Only if you're using Windows, we'll just open the file .bat, and you're done. If you are using a Mac, as I am doing, you must Open the terminal. Here we write the first part of the read file, and complete by dragging the Java icon. We send and we will have our window program. Caution: you do not have to close the terminal window, otherwise the Java program will shut down. Now, to use this program, we have to select the right port, set baud to 115,200, make sure we have selected firmware, GRBL. Only now can we click open. If we look at this phrase, it means everything is going for the best. With the command $$, you will see the GRBL settings. Values 100 and 101 will surely be different. To do this, just copy my actions. At the File Mode window, we can search for the file called Hello Code and start printing. We will see the plotter move. Now, there is a way to start this latest Java program quickly. Exactly as with Windows and the extension file, bat. Follow me, I'll show you the secret to doing so. We open the Automator. Click W, Flow, and Next. Select Shell Script. Let's clear the current text and type Java, less Java, and complete by typing the address where our Java file is located that we want to open. Let's give one now, save. Let's type the name we want. Let's remember to change the file format. Application, it will be the right choice, and we close everything. We will have a nice robot icon in our desk now. Just click on it, and the only Java window will open automatically with the program, Universal G Code Center, without the annoying second terminal window. Magnificent, is not it? Well, we almost finished it. Now that we've finished with the software part, we come back from our plotter and end with the wiring. We retrieve the extension cable for the servo motor, and we enter the connector on the servo motor cable, or straighten the wires as I did. Let's remember the colors used. In my case, red for 5 volt, black for mass, and green for signal. To improve the aesthetics and functionality, we cover all the wires with a PET cable sleeve. Replace the DuPont terminals of the servo motor. Singles will be fine and wiring will be more practical. To avoid damaging the servo motor cable, you must lock it to the base with an electrician clamp. And about half the cable, lock it with another electrician clamp using the special 3D print piece, as you are seeing on video. Before placing the 2 polyl, make sure you have inserted the 3 jumpers under each housing. Connect a sufficiently sized cable piece directly to the jack connector. It will facilitate connection with the 12-volt power supply. Now, to improve the operation of the servo motor, and therefore do not encounter problems with operation, get a piece of wire, and connect its ends exactly as shown in the picture. On one side directly on the 12-volt positive terminal, the other side, in the VIN of Arduino pin. Now is the time to connect the CNC Shield over to Arduino Uno. Important: before connecting any cable, you must calibrate the Pololu A4988 with the right reference voltage. To do this, I refer you to my video about setting up the drivers. Then proceed to the connection of the two motors. During the final tests, it may happen that you have to rotate these two connectors by 180 degrees. Now we connect the servo motor to the CNC Shield. To do this, we will connect the red and black cables visually to the 5-volt and GND board, while the signal cable, green to video, will connect it to the white pin of the CNC card, which is related to the Z+ signal. That's the Arduino pin 11. And after breaking the pen arm, even after 2 prints, I recommend printing the modified 3D piece, and more robust. Compliments. You've finished the drawing machine. Now you have the opportunity to open your mind, and give space to your imagination. Good job. My plotter is also glow in the dark. Thanks for watching. If you liked the video, you found it interesting, do not forget to give a like. If you have also made a drawing machine, spend 2 minutes and let me comment on the video. Finally, subscribe to my channel if you have not already done so. Thanks for the support. I look forward to the next video tutorial. Ciao.